Now we are going to look at classification and clustering again. We already saw that classification and clustering are both used for categorical values. In classification, you already know the y-axis, like people defaulting or people survived in the Titanic world. In clustering, you don't know what clusters exist, so you let the computer find that. So there is something called k nearest neighbor. It's a classification model, and what it does is that it's a subset of supervised learning, and it finds out which neighbor you are closest to. So once you say that these are my neighbors, or this is my data, and these are the 4 blocks that I found out, and if you find out these 3 dots, you can find out that okay, these are the people who belongs to these 4 neighbors. Therefore it's called k nearest neighbor, and it's called supervised learning because you already define how many k exist. So there are 4 groups here. In k-mean clustering, you have to define the clusters, and then you have to define where you're going to put that. So not just that, you have to define the number of clusters. After the clusters, you have to define which thing it belongs to, or you have to define how many clusters were found. So in this case, you have 2 different clusters, and we were trying to cluster it to find out, to put everything into the different clusters. So k-mean clustering is a type of unsupervised learning which is used when you have unlabeled data, that is data without defined categories or groups. The goal of algorithm is to find groups in the data and find the number of groups by the variable k. The algorithm works iteratively to assign each data point to one of the k groups based on features that are provided. So that is clustering. Now in the book and in the examples that we are going to see on the hands-on, we are going to use iris data set. This is about 3 plants, 3 flowers, and we want to find out which flower belongs to which. If we use, since we also have the label data, we can use supervised learning and use k nearest neighbor to find out where everything belongs to. So these are the sepal and the petal, sepal width and the sepal length, and then you have the petal width and the petal length, or other information that you use would come to in your example. And then based on this, we want to find out which part should we keep something into. So in classification, you would classify things as low risk and high risk customer based on their earlier profile. This is similar to finding out if somebody is going to default or not. In clustering, the cluster automatically gives you cluster with low risk factor and cluster 2 with high risk factor. Maybe they can give a cluster with a medium risk factor if we have something like that. So this is risk classification for loan pays based on customer salary. So we did this all the time, but let's see this with some more examples. So broad ML categories are discrete and continuous. This is for y, or the thing that we want to predict. Supervised and unsupervised learning is whether we have y, whether we know y or not. In classification, you have computer vision, image classification, speech, handwriting, drug delivery. In continuous, you have computer vision, object detection, linear and logistic regression. In unsupervised clustering, you have k-mean, mean shift, large-scale clustering problem, hierarchical clustering, and GMM. In continuous and unsupervised, you have PCA, LDA kernel, and density estimation. This is a k-mean cluster. So in cluster, it tries to find out cluster of its own. So when we run this, and it tries to find out different cluster, whether there are 1 cluster, 2 cluster, 3 cluster, 4 cluster, and it rightly finds out that there are only 3 cluster. So once it rightly finds that out, it marks the cluster, and on the right hand side you have k nearest neighbor, where we already told that these 3 cluster exist and we want to identify something. So when you don't know anything about the data, you can ask k-means cluster to give you a cluster, and then study the cluster and then see if there is a unique thing in that kind of a cluster based on some idea, which then you can find out based on some column. And on the right hand side, you are going to use classification, where you would all tell from the starting where it belongs to. And there are different iterations 1 and 2, which is done by the k-mean clustering algorithm to create those clusters. Now this is another cluster which is group of target that we would like to target for marketing and sales were low income, low moderate income and young, low education, low income, high income, low moderate education, moderate and high education, moderate education, low income and middle age. These are the groups that we can find doing a particular thing. Then you have cluster 1 and cluster 2 and centroid. So these are the centroids and this is the central point, and if a new points come in we have to measure. So once we do before k-means and we have something, then we get k-means and then we can get more insight from our data. This is again 3 clusters, cluster 1, 2 and 3. Now these 3, whether there are 1, whether they are 2, whether they are 3 is defined by the computer and by the algorithm, but we have to be careful of not overfitting. So if we get 3 cluster and 12 clusters, and if we think that the problem is not complex enough, then we'll go with 3 clusters, not 12, because that might be overfitting. So how do k-mean clustering work? Number of cluster k, centroid, distance of object to centroid, grouping based on minimum distance, then no object, move group, and which means that it's going to increase the cluster size and see if it can give you. Now as we reduce the size of the cluster, the accuracy increases, so we have parameters to nullify that. So k nearest neighbor is helped to split 2 or more categorical values, class A, class B. So k-means is unsupervised learning, it's used for clustering. K-means K in the k-means is the number of clusters, typically used for scenarios like understanding population demographic, market segmentation, social media trends, anomaly detection where clusters are unknown. While in k nearest neighbor it's a supervised learning, it's mostly used for classification and sometimes even for regression. K is the number of nearest neighbor used to classify or predict, and it is not the number of clusters. It is used for classification regression of known data, which usually target attribute known is known beforehand. So that is the clustering, and the hands-on of this would be done using the iris dataset.